So now we will discuss the summary of Chapter 4, entitled Network Access. So, to support our communication, the OSI model divides the functions of a data network into layers. Each layer works with the layers above and below to transmit data. Two layers of the OSI model are so closely tied that according to the TCP or IP model, they are in essence one layer. Those two layers are the data link layer and the physical layer. On the sending device, it is the role of the data link layer to prepare data for transmission and control how that data accesses the physical media. However, the media layer controls how the data is transmitted into the physical media by encoding the binary digits that represent data into signals. On the receiving end, the physical layer receives signal across the connecting media. After decoding the signal back into data, the physical layer passes the frame to the data link layer for acceptance and processing. This chapter begins with the general functions of the physical layer and the standards and protocols that manage the transmission of data across local media. It also introduces the functions of the data link layer and the protocols associated with it. Types of connection. Whether connection to a local printer in the home or a website in another country, before any network communications can occur. A physical connection to a local network must be established. A physical connection can be a wired connection using a cable or a wireless connection using radio waves. The type of physical connection used is dependent upon the setup of the network. For example, in many corporate offices, employees have desktop or laptop computers that are physically connected via cable to a shared switch. This type of setup is a wired network. Data is transmitted through a physical cable. In addition to wired connection, many businesses also offer wireless connection for laptops, tablets, and smartphones. With wireless devices, data is transmitted using radio waves. The use of wireless connectivity is common as individuals and businesses alike discover the advantages of offering this type of service. To offer wireless capability, devices on a wireless network must be connected to a wireless access point or the AP. Switch devices and wireless access points are often two separate dedicated devices within a network implementation. However, there are also devices that offer both wired and wireless connectivity. In many homes, for example, individuals are implementing home integrated service routers or the ISRs. ISRs offer an switching component with multiple ports, allowing multiple devices to connect the local area network or the LAN using cables. Additionally, many ISRs also include an AP, which allows wireless devices to connect as well. Network Interface Cards or NIC connect a device to the network. Ethernet NICs are used for a wired connection, whereas WLAN NICs are used for wireless. An end-user device may include one or both types of NICs. A network printer, for example, may only have an Ethernet NIC and therefore must connect to a network using an Ethernet cable. Other devices such as tablets and smartphones might only contain a WLAN NIC and must use a wireless connection. Not all physical connections are equal in terms of the performance level when connecting to a network. For example, a wireless device will experience degradation in performance based on its distance from a wireless access point. The further the device is from the access point, the weaker the wireless signal it receives. This can mean less bandwidth or no wireless connection at all. All wireless devices must share access to the airwaves connecting to the wireless access point. This means slower network performance may occur as more wireless devices access the network simultaneously. A wired connection channel over its Ethernet cable. This is important when considering some applications such as online gaming, streaming video, or video conferencing, which require more dedicated bandwidth than other applications. Over the next couple of topics, you will learn more about the physical layer connections that occur and how those connections affect the transportation of data. So the summary, the TCP or IP network access layer is the equivalent of the OSI data link layer and the physical layer. The OSI physical layer provides the means to transport the bits that make up a data link frame across the network media. The physical components are the electronic hardware devices, media, and other connectors that transmit and carry the signals to represent the bits. Hardware components such as network adapters, interfaces, and connectors, cable materials, and cable designs are all specified in standards associated with the physical layer. The physical layer standards address three functional areas: physical components, frame encoding technique, and signaling method. Using the proper media is an important part of network communications. Without the proper physical connection, either wired or wireless, communications between any two devices will not occur. Wired communication consists of copper media and fiber cable. There are three main types of copper media used in networking. First is unshielded twisted pair or UTP, shielded twisted pair or STP, and coaxial cable. UTP cabling is the most common copper network media. Optical fiber cable has become very popular for interconnecting infrastructure network devices. It permits the transmission of data over longer distances and at higher bandwidths or the data rates than any other networking media. Unlike copper wires, fiber optic cable can transmit signals with less authentication and is completely immune to EMI or RFI. The number of wireless enabled devices continues to increase. For this reason, wireless has become the medium of choice for home networks and is quickly gaining in popularity in enterprise networks. All data link layer protocols encapsulate the layer 3 PDU within the data field of the frame. However, the structure of the frame and the fields contained in the header and trailer vary according to the protocol.